Hello dear VTU students, hope you are all doing well. If you are having the backlogs in the subject 18MAT31, I know most of the students are having backlogs. So in this video I will be discussing the super important questions from the Fourier series first, then later on I will be uploading another modules. Okay, in this video especially we are going to deal with the important questions of Fourier series. I have taken here the most frequent asked question, that is find the Fourier series of the function f of x is equal to x square in interval minus pi to pi. Okay, so how to solve this particular question? First of all, in the Fourier series we have to check the given function, is it even or odd, then accordingly we can proceed for the Fourier series, right? How to check whether this function is even or odd? Let me do this thing over here. So in solution I can write down, first of all we have to check is this function even or odd. So instead of x you have to put minus x value. If we are getting f of x as positive, then we can say that function is even. If the function we are getting negative, then we can say that function is odd. Okay, let me put this x over here now, minus x. F of minus x is equal to, instead of x I am taking minus x, so minus x whole square. Now f of minus x is equal to, minus x whole square is nothing but x square. This is your x square. Now I am getting positive x square, same function I am getting, that is f of minus x is equal to f of x. Okay, so this means that we are getting f of x positive, the function is even, the function is even. So for even we have Fourier series. So for even function we have Fourier series f of x is equal to a naught by 2 plus summation of n running from 1 to infinity an cos of x. So this is, sorry, cos is the standard formula of the Fourier series. F of x is equal to a naught by 2 plus summation of n running from 1 to infinity an cos of nx. Now we have to deal with this these Fourier coefficients, that is a naught is the Fourier coefficient, an is the Fourier coefficient. Once we will get these two values, then we have to put these two values in this particular formula or particular series, we will get required Fourier series. So let me call it equation first. Now for a naught we have formula. So a naught is equal to 2 by pi 0 to pi f of x dx. Sorry, let me change the pen first. So a naught is equal to 2 upon pi 0 to pi. What is the f of x value? Function, given function is x square, so x square dx. Now let me integrate it. A naught is equal to 2 upon pi. What is the integration of x square? It is nothing but x cube divided by 3. Once you are integrating, means in the integration what you have to do, if it is x square, so you have to do x2 plus 1 divided by 2 plus 1. That becomes your integration. So x cube divided by 3 is the integration of x square. So likewise, whatever the values are there, x raised power 4, so you have to do x raised power 4 plus 1 divided by 4 plus 1, like that you can integrate the required function. So x cube by 3, limits will shift from 0 to pi, right? So a naught is equal to 2 upon pi. Now applying upper limit and lower limit, so pi cube, instead of x you have to take upper limit, that is pi cube divided by 3, minus lower limit is 0, that is 0 cube divided by 3. Okay, a naught is equal to 2 upon pi, this is your pi cube by 3, and this is 0 by 3 is nothing but 0. Now pi and 1 pi will get cancelled from this. What we are left with, 2 into pi square. Okay, so 1 pi is cancelled with this 1 pi. Now we have pi square here divided by 3. So this is your a naught value. You can write down also a naught, this 2 you will get here, a naught by 2 is equal to pi square by 3. We are getting this much. So a naught by 2 we are getting pi square by 3. Now what we have to calculate? We have to calculate an value. Okay, so in the next page I will solve. So now dear friends, we have to calculate this an value. So see here, an is equal to 2 by pi integration of 0 to pi f of x cos of nx dx. This is the formula for an. Okay, an is equal to 2 by pi integration of 0 to pi. What is the given function? That is x square cos of nx dx. Now you have to apply Bernoulli's rule of integration. So applying Bernoulli's rule of integration. So I can simply write, apply Bernoulli's rule. An is equal to 2 divided by pi integration of this 0 to pi x as it is. Sorry, you can simply write down x square as it is. What does this Bernoulli rule of integration says? So x square as it is, integration of this cos of nx. What is the integration of cos of nx? It is nothing but sine of nx by n. It is the integration of cos of nx. Now minus differentiation of this x square, that is 2x, and again integration of this term. So what is the integration of sine? That is minus cos of nx divided by, here we have n, here you have to take n square likewise. Okay, now plus differentiation of this term and integration of this term. Okay, you have to simply proceed like this. So differentiation of 2x is nothing but this is here minus actually, and x differentiation with respect to x is 1, so 2 ones are 2, minus 2 we are getting, and integration of this term again. So what is the cos nx difference, sorry, integration? That is sine of nx by n cube. So this is all about the Bernoulli's rule of integration. Again I am repeating this. First of all, we have the function x square cos of nx. We have to just take x square as it is and integration of cos of nx, that is sine nx by n, minus differentiation of this first term, that is x square, so differentiation is 2x, and integration of sine of nx by n, that is minus cos of nx by n square, plus differentiation of this term again. So differentiation of 2x is nothing but 2, so minus 2 why I am taking, just because we have sine here minus, so minus 2 multiplied by minus as it is, and integration of this cos of nx by n square is sine nx divided by n cube, and limits will shift from 0 to pi. Hope you are following. Now once you are applying limit, upper limit, so it will become sine of n pi. Wherever you will get sine of n pi, you have to just make that term as 0. So you can write down like this 0, and here we have again sine of nx. Once you are applying upper limit, you will get sine of n pi, that will become your 0 again. It is the formula, actually standard formula, that is sine of n pi is always equal to 0. Hope you will remember this much. Now an is equal to 2 upon pi. Now what we are left with, minus into minus is plus, so 2, and n square I will take out, so 2 by n square, and we are left with x cos of nx. Okay, and limits are 0 to 2 pi, 0 to 2 pi, 0 to pi. We have interval over here, that is an is equal to 2 by pi, and this is your 2 by n square. Now apply limit, upper limit and lower limit. So pi is the upper limit, instead of x you have to take pi, so pi of cos of n pi minus lower limit is 0, so 0 multiplied by this you will get 0. Okay, now an is equal to 2 2s are 4, and pi into n square is pi n square multiplied by this pi cos of n pi. So cos of n pi, we have formula, cos of n pi is equal to minus 1 raised power n. Okay, now instead of cos of n pi we have formula minus 1 raised power n. Now this pi and this pi will get cancelled out. An is equal to 4 divided by n square into minus 1 raised power n. This is the answer for this particular an. This is Fourier quotient. Now you can put down these two values, a0 by 2 and an value, in this Fourier series. So f of x I can write down. So instead of a0 by 2 we have value pi square by 3 plus summation of n running from 1 to infinity, summation of n running from 1 to infinity, an cos of nx. So what is the an value? So 4 by n square. I will take 4 out, and inside we will get minus 1 raised power n divided by n square, and also we have this cos of nx. So cos of nx. This is your required Fourier series for the given question. Hope you have understood the concept. Similarly, you can solve the varieties of problems. So thank you so much.